All right, Princess, if you're good to go, I can stop. All right.
Okay, we are good to go.
All right, thank you.
Can you hear me? Okay, thank you
Yeah, I can
very
hear you.
much. Good morning, good afternoon, good evening to everyone who is joining us for the February technical lecture organized by the Society of Petroleum Engineers Lagos section. We appreciate you taking your time to be a part of this lecture that will promise to be very useful and will be worth your while. It is titled Utilizing Risk Analysis and Probabilistic Methodologies for Intervention Operations. SPE is committed to technology and technical knowledge dissemination, and that is what we're still going to be progressing right about now. So to kickstart today's meeting, I'll start by introducing myself. I am Ofochinyere Princess, the Career Guidance Chairperson for SPE Lagos section, and it will be my humble privilege to take you through this section as the moderator. To go for a few safety moments that I would like to share with you. I believe that we are joining from different locations and through different means. While we join, let's ensure that in whatever location we are joining from, let's ensure that we are aware of all our emergency rules. Let us know how we can act in case of emergency, where we would have to escape from, and how to be alert. Also ensure that we are not distracted during this lecture. It's important that if we are taking this lecture and driving, it would be important for us to ensure that we are not distracted in the activity. So we can always park and listen to this or have someone else take up activity on our behalf. So today's lecture promises to be insightful. We would be taking question and answers once the technical lecture is completed. So would you want to comment or questions? Please drop it in the chat box. During the period of question and answer, we'll ask you to raise your hand and either take your questions or we would read off the questions that you drop in the comment section. So following this, I would invite the section person by name of Oluwabi Awotikun, who will be giving us the opening remarks, and thereafter we'll be introducing the presenter and going into the lecture proper. So thank you very much for joining us once again, and a virtual round of applause as we invite BE to the virtual podium. BE, over to you for your opening remarks.
Thank you very much, Princess. Glad to be here. Good afternoon and good evening, everyone. Thank you for joining us today for this technical meeting. I think SPE Lagos continues to try to out various technical events, and one of such is our monthly technical meeting that's taking place this month. And last month we had it with Dr. Rita Okorafor. And so I would say today we have a great speaker who will be utilizing risk analysis and probabilistic methodologies in subsea intervention operations. I think it's going to be a very wonderful time listening to him speak. And I want to believe that we're going to take one or two things, that we can also apply on our job, or if you're a student to apply in your research, in school. I would say SPE, and vision is to ensure that push out technical information and we disseminate it across, everyone, and ensure that we continue to push the frontiers of technical research. And so it's an honor to welcome you and give the opening remark at this technical. If you can still do us a favor to share this with your colleagues who are not joined yet, please share. The more the merrier. Over to you, Princess. Thank you.
Thank you very much, B, for that opening remark. So we'll be progressing into the session proper. We're going through the speaker's bio. The speaker is an adept technical leader. He is a senior drilling engineer with 10 years post-graduation work experience spanning across land, swamp, shallow, and deep offshore drilling operations. Over the years, he has worked with design operations, support, and delivery of various exploration, appraisal, and development wells for various marginal and IOC and abroad. He's currently the well engineering team leader at H-PTP Energy Services, and is currently the chairman of the training committee for SPE Lagos Section 61. He has contributed over 15 SPE papers in his 12 years and has won the Technical Paper Presenter Award and also other numerous awards, most recently the Regional Award for Drilling and Completions in 2023. He holds a bachelor's degree in Chemical and Process Engineering from the Federal University of Technology in Mina, and he has a master's degree in petroleum engineering from IPS/IFP School in France. And he also has an MBA from the Quantic Business. It will be my humble privilege to welcome to the virtual podium to take us through this lecture, Mr. Ugo Okoli. Ugo, please, over to you to take over. If you're speaking, you're muted. Please unmute yourself.
Oh, wow. So sorry about that. So I said, thank you very much, everyone, for coming in here and listening to this. I won't say pretty much this is a teaching session. I'll say pretty much it's sharing, because I can bet that a lot of us have actually done this, but perhaps inadvertently or not just, or perhaps did it, I didn't record. So I'll start off with quickly why I write my papers or why I kind of document most of these things, and it's particularly this paper. So it was at a time, the company I was working with at that time, Adax Petroleum, wanted to increase production, but however, at very little cost or little capex. And that meant intervention, especially for all the assets. I was on the asset that we operated the field. It was pretty much shallow water asset. We operated with a semi-submersible, and then we had to go and do some intervention on some of these wells. Now, some of these wells, there were different scope of work for some of them, but this particular well, there was a plan to drill through the Christmas tree. So before I just in and start giving us all the details, this is pretty much what the topic looks like. I've actually presented this paper before in 2016, but why I decided to bring it to the table again is I felt it didn't get the recognition that it deserves, and that's why I decided to speak about it again. So quickly jumping into the outline, I'll be introducing the topic and I'll be talking around the research objectives. Then I'll move straight into the theory, what was used. Because we drill engineers usually use the deterministic method. So I'll explain that for a bit. They are both probabilistic methods, that's stochastic and deterministic. The only difference is that deterministic, you're almost ascribing what you want to the model. But for stochastic, it's more random. And we'll get into, when we get in there, we'll see the details. So now I'll talk about the method, speak about the result after we did the costing and we drilled the well. Then I'll go ahead to conclude and make recommendations. So what was the design and operations objective? And like I mentioned at the time, we wanted to increase production for the company in general and with very little capex. So part of what we planned to do was to drill through the horizontal Christmas. At the asset I was working on me and my team, We operated that field with pretty much the semi-submersible, and most of that asset was a subset with horizontal trees on the seabed. That's for I'll try and break it down as much as I can for those of us who are not engineers, so who are not even in the oil and gas industry that are in this meeting. So at the time, we had a lot of wells, circa 20-25 wells in that particular field. This well was first drilled and completed in about 2010, and at that time in 2015-16, because of after the economic crunch, decided to re-enter these wells and increase production. On this particular well, it had produced a particular reservoir, and the plan was to get into this well, plug back the zone that had produced, drill through the Christmas tree that we're not going to take off the Christmas tree. We'll go ahead, drill through the Christmas tree, and that was drill about 3,000 feet of horizontal, near horizontal to horizontal through this Christmas tree, and continue production from this particular well. However, there were different, we had different constraints. Number one was this tree wasn't designed to be a drill-through tree. But the only reason why there was the appetite was that we had done an intervention before sometime in the past, but it was just 300 feet. And it was vertical to near vertical. So there were no issues, there were no complexities foreseen at the time. So the same technology, or rather the same procedure, was decided to be applied to this well. But we looked at it and evaluated, is it right to apply the same method to increasing production for this well? So that's pretty much what the objective is about. And before we made that decision, we had to sit down, risk assess this well, what exactly we're trying to do, and not just risk assess, look at, not just costing the well and looking at the timing that we're going to use to intervene this well, but also looking at the risk. Now, most of us drilling engineers, when we want to design wells, or when we want to cost wells, which pretty much is the area of well design that I don't like because it's very non-technical. You take offset wells. When I say offset wells, perhaps wells that have been drilled in that particular environment. We take the timing associated to delivering these wells. We take that timing and we try to produce our cost our well. In fact, some of us even go very detailed. We go into very big databases like the Rushmore reviews. We try to get timing and try to use that timing to cost these wells. Now, that's what I mean by it being our method being determined. You already have a timing. So you're pulling out that timing, you're pulling out that average timing, and you're putting it to your model and try to use it to determine the time for that well and the associated cost. Now, you haven't looked at a lot of other things. I'll use a very good example. What can go wrong? Or the things that could go wrong. I'll give a very good example. I was the drilling superintendent for a particular marginal field operator here in Nigeria. And just when we started the project was when COVID struck. Of course, we had costed the well. Of course, we had designed the well. Of course, we had done everything we're going to. COVID was never in the picture. So we started the project and all of a sudden COVID struck. We had to optimize. We had to look for ways to still drill those wells, deliver those wells without most especially not having anybody killed, because then there was no clue what was going on. There was no clue how it could be curbed. There was no clue about anything. So we still went ahead to drill these wells and eventually deliver this without killing anyone. So, but the timing associated to delivering those wells, it spread because there were a lot of other things we had to do that were long than the necessary time, or rather the time that we planned in delivering those wells. So this wasn't factored into the timing. I'm just using this as an example for us to know. COVID doesn't come all the time, but when you are able to think in diverse ways and think of all the things that can go wrong and factor that into your operations, factor that into your planning, it goes a long way to help advise whoever is bringing out the money the management that, look, this project we're going into, this well we're planning to drill, or this project we are venturing into, it's be economical, it's going to bring money, it's going to bring some the bottom line is going to be I mean, big enough, and it's going to bring money to the table. That's why I feel that this when we listen as I speak, let's not just think or assume that it's drilling related. You take this into any project you're working on, be it a house you're trying to build, be it a car you're trying to fix, anything. Factor in the risk, every possible risk that can impede the project. Factor in anything, and that way you're hopefully able to have a wider picture on what you're going through. So that's pretty much introducing the topic. So the research I think I've already spoken around this. You would want to think about everything, so that for two reasons. Number one, you wouldn't want to mislead your management. You tell them that, hey, it's all hunky-dory, and you go in there and they find out that, look, you're in trouble and you are not able, I mean, they've lost so much money, and the amount of oil that you're going to recover doesn't even pay for the well, talk less of bringing profit to the table. You also shouldn't be so pessimistic, factor in a lot of risk that it becomes so bloated, and by the time you're presenting the timing and the cost to the project to the management, it scares them away. So you don't want to do that. So jumping straight into the case study, the well was drilled offshore shallow water of 445 feet. It was built with a semi-submersible. The rig at the time was a Saipem rig called Scarabeo 3. Station keep was moored. It was a second generation jackup. The rig elevation it was 105, and the plan was to kill this producing well, re-enter it, complete it, drill a sidetrack, and recomplete that well. So that's pretty much how we were positioned on the Christmas tree where we went there to drill the well. So we had two major scenarios. What you see in the middle here is the well schematic as it is while we were producing. The first scenario was get there, recover the Christmas tree debris cap. There's supposed to be a debris cap up here. Recover the debris cap, run a BOP on the Christmas tree, that's your pressure barrier. Recover the internal tree cap and the crown plug, that's the internal barriers. Kill the well and recover the upper completion, that's this. Then you abandon this reservoir, which was at the time was producing but had watered out. Then you drill a sidetrack, but you don't take off this tree. Because the way the horizontal tree works is, after you drill your well, let's say we're drilling the well from start, you would have drilled your well, run over completions, put in a barrier before you pull out your blowout preventer, that's your Subsea BOP. Then you install Christmas tree, install the BOP on the Christmas tree, because the upper completions has to land in the horizontal Christmas tree. So what team looking at scenario one we're thinking of is, see, why not we just land the BOP on the Christmas tree and just go ahead to drill. And once we are done drilling, kill the well, abandon the well, recover the completions, go in, drill. Once we are done drilling, run the lower completions, run the upper completions, and the Christmas tree. And once we're done, we pull out the BOP. That was the thought around it, because that saves a whole lot of money. Not just that, in drilling, looking at scenario one, you wouldn't have to take out the flow lines. Don't forget that I forgot to mention that there's an FPSO in that field, flow lines connected from every well in that field to the FPSO. So to drill this well means you have to disconnect the flow lines, and to do that, you need the dive suppressor. So when you do that, after drilling this well, you have to look for dive support vessel again to hook it back up. So that thought was around it, and if this is done, if scenario one is done, we won't have to look at all that disconnecting the well. So it's just, we go in, do the intervention, drill the sidetrack, pull out the BOP, the rig goes away, you start on your well, it's connected to the FPSO, boom, and production and goes on. Now, the second scenario is, I would say, doing it the way, quote unquote, doing it the way, like the very careful way. So we go there, put on the BOP, kill the well. After killing the well, we, as in with the BOP installed, but before you do any drilling, you take off the BOP. So which is what this highlights. Those are the extra steps. So you pull the riser and BOP, recover the Christmas tree, then run the riser and the BOP, that's without the Christmas tree, then drill the sidetrack. So the Christmas tree is out of the way. Then when you're done, you now pull the BOP again, install the Christmas tree, then all the BOP on it. Now, what this does for you is, why it seems expensive is, this highlighted steps you see here, easy, 7 extra days. And even with the second generation drill semi-submersible, cost you about 250K easy per day. This is just the rig cost. So if you're looking at the spread rate, you're talking about $600,000 to $700,000 per day. So thinking of saving that for circa 7 to 10 days is a whole lot of money. I've not even spoken about when the amount of oil you're going to lose. I mean, the time you're going to lose, because you're going to have it disconnected, and if it's disconnected after you finish drilling the well, it is when you get a dive support vessel that you are able to reconnect. If you do dive support vessel, I mean, you just keep losing oil, and it's only when you get that. So that cost isn't even factored in here. But again, what are the advantages or disadvantages? The disadvantage of the second scenario is that it's more expensive, but you don't get to damage anything, and you sort of move easy, and the risk associated to this steps here is very minimal. So just to throw a spotlight on what the Christmas tree looks like, the horizontal Christmas tree, I mean, the piece of equipment everybody is about, just to throw a spotlight on. This is what it looks like here to the left. This is what the block looks like. Then looking internally, the area we're worried about is the area around here. So this you see here is the internal tree cap. We'll first recover this, the debris cap, recover this, then recover the crown plug before you're able to access the well. Then this is definitely when in the upper completions, it has to come out with the tubing hanger. The profile here is what we're worried about, because if for any reason while you're drilling, you're having lateral vibrations and impacts across the wellhead system or the Christmas tree itself, you will damage something. And at the time, I think Christmas trees were $7 to $8 million. So imagine you're trying to save cost and you eventually damage this. You'll end up putting back $7 to $8 million back on the capex. So that's what everybody was worried about. If we're going to do this, we're going to do this correctly. Now it's the job of the engineer to look at this properly, risk assess it, cost it, and bring it to the table. I mean, bring it to the management and advise them accordingly. So I just thought to trace spotlight on what the Christmas tree looks like. So I think I already spoke around it, what the advantages are. So drilling with the Christmas tree, straight up lower cost, but what are the disadvantages? So the horizontal Christmas tree, because of the drill string rotation, you could damage the inner profile. I mean, or cuttings while you drill could erode that area. Again, secondly, the horizontal Christmas tree cannot, rather is not recommended by, was that particular Christmas tree, wasn't, there are a couple of drills, but this particular one, even though in the life, when the FDP was done, yes, there was plan for intervention, but drill through them. So the risk of getting damaged, when you factor that risk, knowing that you might damage it, that will make you want to mitigate damaging that tree. So what would you do? Perhaps you want to slow down your ROP, as in your rate of penetration, thinking that, okay, if I do that, the axial vibrations, lateral vibrations will reduce. I won't have that much impact. Please, I'm going to try to save and not damage anything. But when you're doing that, there's a knock-on effect. What happens? Your ROP slows down, and when your ROP slows down, you have increased number of days, and that's translating to cost. And not just that, that area, because it's a brown field and some of the sands they're already depleted, and with depletion comes formation compaction. And when we have formation compaction, you have wellbore instability. you will have wellbore stability issues around that area. And if you have any shield dependent, time dependent shields in that environment, they will come at you like we had in that particular field. So you're trying to save costs doing something, but there are other risks that build and get at you while doing that. Finally, the plan was to run expandable sand screens. That's what you see as ESS here. So running ESS is a very, very fragile piece of blank pipes that you have to run to prevent sand from coming into the wellbore. If it gets into an area, I think then at the time, I think the maximum you could set on it was about 10 to 12,000 pounds. Anything above it, hello? Am I? So anything above it crushes that pipe, and you might have a junk in the well. And if you have a junk in the well, that means you have to sidetrack. So looking at drilling through the tree, the advantages is success rate is higher. You don't get to damage the tree because you have recovered it. You also have the opportunity to service that tree. Because when you put out, I mean, you take it to base, they'll look at all the valves. It's been down there in water. Of course, even though you have electrodes, there's still possibility of some sort of erosion. So you check it, check the valves. You get the opportunity to do some service, and that increases the time. I mean, or rather, that reduces the being time between failure. If any valves we're going to fail. You're also able to drill that well the way you should, because you're able to spin the pipe as much as you want. You'll be able to, and with spinning the pipe as much as you want, you're able to clean the hole. And with all those drilling parameters in place, you drill the well a lot faster. I already spoke about the disadvantages, which include once you disconnected the flow line, you need some time to connect them back, and you lose oil in oil in the tank. I mean, you slow down oil in the tank. Then also, I also spoke about the extra time for rigging or bringing down equipment. So when you have all these scenarios playing at you, it's kind of difficult to make a decision because each one of these scenarios have their advantages, but again, have their disadvantages. And that is where the probabilistic modeling comes in, because you have to look at every detail and properly put in the risk. And once you factor that in, once you factor the risk into your cost and time modeling, it helps every part of your team make very good decisions. So moving straight into it, looking at this picture, I don't know, quickly, just in 30 seconds, can anybody identify this picture? Can anybody tell me what painting things this is? Anybody quickly? Yes, Chinyere, go ahead. Yes, I see hand raised up. Chinyere, go ahead. We don't hear you. You're mute if you're speaking. Anybody else? Because we can't hear you, Chinyere.
And this is Mona Lisa. Yes.
Okay, thank you very much, Ephraim. Yes, it is the Mona Lisa. But I'm sure you broke an arm and a leg to recognize the picture. My perspective, this is how I see deterministic modeling, because it doesn't paint the real picture of what it doesn't paint the true picture of what it should be. You are taking like I mentioned in the beginning of the presentation, as a drilling engineer, we are using offset records, okay, to run 1,000 running 1,000 feet of pipe in the hole should take us an hour. Drilling and running 9/5/18 casing, should be able to do 15 to 12 joints an hour. We're using all those numbers to build models, to paint pictures and cost our wells and give them to the management that these things can happen. Let me use a very good example. Say you're drilling an area where there are faults. Perhaps you've heard it's a listric fault. but you don't know that somewhere there's an active, then you've drilled like 4 wells in that environment, then this particular well, you've used the time and cost for these 4 wells to cost your own well, and the well you're going to drill is the closest to that particular active fault, and not just close, it's parallel to that fault, and you haven't factored this into your head. Hey, I should just go there, slam bam, and if they're drilling, come on, they drill this well in 30 days. I should be able to do this in 30 days. In fact, I'm going to optimize. We should be able to do this in 25 days. Then you haven't factored in everything that could go wrong, which includes drilling very close to that active, drilling parallel to that active fault, and you go there, all of a sudden, you lose everything in there. So as a drilling engineer, trust me, guys, it's your fault. I'm not trying to be sarcastic about that, because as drilling engineers, you should be able to look, you should be able to have it in your head that whatever can go wrong will go wrong. It's better that it is said, it is mentioned, it is mitigated against, than it doesn't even happen. Then it's not seen at all. We're all working, everything is honky-dory, then boom, it happens. But when you paint this picture with every piece of data around you, then it really looks like the Mona Lisa we know. You paint the picture using every condiment. You see, looking at the Mona Lisa we have on the right, there are a lot of things missing. You look at the part here, you see that the part is really clear. We see that there's a road pass here. It's not so clear here. It's not so clear on the real picture. But again, that could be very deceiving. There are a lot of things in the real picture that are missing on this one on the left. So I see the stochastic model because it's random. It's random, but it takes everything. You've put in enough details, and you've allowed the model to paint your picture of what you have and what can actually go wrong. You are not determining what should go wrong. You're not being, like the name, you're not being, it's not deterministic. You're allowing the model think for itself and prefer a solution. And that way, not really prefer a solution, but telling you exactly what the situation is. So just having a quick look at both of them, I already defined the stochastic involves probability and randomness. So it kind of is able to think for itself. For deterministic, no role or randomness in future results. It's almost like, hey, this is what I want. This is how it should be. The stochastic provides wide variety of potential outcomes, so it should be the answer. It can handle complicated nonlinear relationships, works better with dynamic circumstances. Models are harder to build, and that's why a lot of engineers run away from it. It takes a lot of time to build. I mean, imagine having to drill just one well or cost just one well, and you have about 15 months for it. That's thinking about, for every well, you're thinking about 6 different things that can go wrong for one well 15 times. So for this particular well, for the same well, you're thinking, okay, this can go wrong, 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 and you've built it into one scenario. Then for the same well, you're thinking of every other thing that could go wrong. Perhaps it's in the first model, and there are some things that are not in the second model. And imagine doing that 15 times. See, it's actually much, much more robust. There is no way everything you've highlighted in each and every one of the scenarios one of them will not jump at you. And when it jumps at you, it's not going to be new, because you've not just thought about it, you've thought about a way to solve it. For deterministic, simple to implement, simple to maintain, very quick to use. So we just go punch numbers. Hey, it's here. This is what the cost should be. Sometimes it works, most times it doesn't. Just to talk us through what for this particular case study, normally then in the comments, for that was the flow path. You just picked up the offset well record, looked at the details. Then we had an Excel building then at the time, thing called out risk. So you took the minimum time for performing that operation, you took the mean time, you took the maximum time, then you let the Atrix, you let the tool, the Atrix building to run it for you. So what it does, it uses multi-Carlos iteration as well, but already you've given it numbers to work with. For example, testing the BOPs. So say low M 5 hours, time 8 hours, maximum time 15 hours. So when it runs it, you see that the variance between the mean time and the maximum time is quite large. You've already told that the mean time is 8 hours. It's going to try and look for a number that falls between the 8 hours. When you look at the answer, it's going to throw at you. It's going to look for the mean time between 8 hours and 15 hours that you give as maximum, but with a little bit of skew to the minimum time. So when it's throwing a number, it's throwing perhaps maybe something like 9.5 or 10, telling you that that's what you should have for your well. But again, don't forget, you have the veto power to give the maximum, the minimum time, mean time, the maximum time. You put in those numbers. And I can remember then as drilling engineers, if you want to reduce the particular, you can actually play with it. So that's being determined. It's not being factual. But for the stochastic, you're using the same offset records. You are using the same probability model, but this time you're making it stochastic. You're making it random. And how do you do that? You've added some risk to it. So you are putting in those risks and you're using it to build the models, and using it to build those models, you're using it to build the timing. At the end of the day, you're coming out with something much more robust. And what does it do for us? Okay, so for this particular well, what I did was I used at risk for the deterministic modeling. Then I used Oracle Crystal Ball for the stochastic modeling. Now both of them can actually do the same thing. It's just that I wanted to put in the limits, but I wanted to put in the limits for iteration. At risk couldn't do it for me. Oracle coder. That's why I used Oracle Crystal Ball for this. So this was what I did. This was what was done using to build the model. So as you can see, I imagined 15 different ways of what could happen. So in these different columns, so number one, drill the Christmas tree in place. Was there damage to the Christmas tree? Did we have hole restrictions pulling the BH out of hole? I mean, looking at wellbore stability issues. Did we have restrictions running the ESS? Did we have issues running the dummy assembly? I mean, if you have issues, so you have to run a dummy assembly to clean the wellbore. Did you get stuck with the ESS while you were running in? Did you get fully stuck? You had to abandon the completions and sidetrack, then change your mind and go ahead. I mean, go ahead and rerun open ESS. Else, if it wasn't impossible, go ahead to complete with a K-Stow ESS. And finally, did you suspend the well and replace the Christmas tree? So these are all the things we factored in. I'll give you an example. Scenario one. Let's assume scenario one, I call it the best case scenario. So did we drill with the head in place? Yes. Did we damage it? No. Did we have restrictions while pulling out a hole? No. Means hole was slick. Did we have restrictions running ESS? No. Did we have to do a dummy run? No. Did we get the ESS? No. Did we abandon completion, etc.? No. Did we recomplete with open hole ESS? Yes. And did we have to suspend the well or replace the Christmas? But everything went. So you see, it's like the best case. Let's look at scenario 13. For scenario 13, did we drill the Christmas tree? Yes. Did we manage it? Yes. Did we have restrictions while coming out of hole? No. So that deceives you, making you think that your hole is slick. Did you have restrictions running the ESS? Yes. So you pull out the hole, the BHA, and it didn't tell you anything. I mean, the hole didn't give you any feel. Then going back in with the ESS, which is much more, the on your drilling assembly, the biggest tool there is your bit. So it's possible that your bit, whatever your bit passes through, the other guys will come out easy peasy. But for the ESS, it's all pipe. So it's one size. Everything going down in, it's more rigid. So the BHA might come in, and that I'm just trying to explain why that can happen. So your BHA comes out of hole easy, but when you're running your ESS and your expandable sand, you now have issues. So you now pull that out of hole and go ahead to run your dummy assembly to clean the wellbore. You do that, then decide, hey, let me just go back in. And guess we'll go back in, and Murphy's law happens. you get stuck. That whatever can go wrong, went wrong. You get stuck. So did you now abandon and sidetrack? Yes. Guys, don't forget, this is all money going down the drain. So you go ahead, do a sidetrack, then because you've done a sidetrack, look, I'm not going with ESS anymore. You decide to run a liner, cement that off, then run Keystone ESS and complete the well. Then, but again, don't forget, somewhere here, you've damaged the Christmas tree. So what happens? You need to change the Christmas tree. So I call this a scenario from hell. This is like everything that can go wrong went wrong. So that is what you see on this slide. In green is scenario 1. Look at the P10 number of days. That's the P10. So P10 is like best, P50 is like mid, P90 is like the worst thing that can happen to you for that particular scenario. So that's what I just explained in the other slide, drilling with Christmas tree in place, no damage to the tree and all that. So your P10 number of days, 1.23 days at 32 million. While worst of it is 60 days at 26 million. Then I have the next one highlighted, scenario 10, which was the worst case. I mean, you can take your time and when perhaps the circulated, look at other scenarios that we generated. So drill the Christmas tree in place, damage the Christmas tree after drilling and testing the Christmas tree. We ran ESS, we got stuck. Then we had to run and cement 7-inch liner, then complete as case for ESS. So look at the P50 cost. P50, sorry, not P10. P10 is $52 million. The P10 is even higher than the P90 of scenario 1. So that can tell you how bad, how really bad it is. So imagine presenting scenario 1 to your management. That says the worst thing that can happen. This well is going to be a big producer, blah, 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 blah. You go in there, what's that we'll spend 50, if everything go $50 million, then all this happen and you end up, this is all this happening and you recover quickly. Then you end up spending $55 million, or maybe even the P50, $78 million. So, I mean, they probably might not say anything to you, but trust me, you're gonna get some reaming later. This is just putting out the scenarios in different places and because again, scenario 1 I have in green showing the P10 to P90 and P10 to P90 days and the P10 to P90 cost. Then also for the I also highlighted scenario 13 because that's the worst, just for emphasis. So this is actually the best slide any management want to see, because what we did was we put out a spread for them to see that says this is what we have. Up here, you have drilling with the Christmas tree, please. It tells us that we can be as cheap as $32 million, but as cheap as $32 million, but as bad as $88 million. And you can go from 32 days to 110 days. But if you take out the Christmas tree and everything goes as it should go, you can spend just 34 days. So look at the variance here. So what am I mean, look at the variance here. What am I thinking? I'm thinking of moving quickly and spending 32 days. Meanwhile, if I take it out, I might end up spending 34 days. I mean, even if things go so bad, even with increasing risk. And the worst I will spend is $66 million. So they put everything down on the table and like, look, guys, there's no point actually. Remember the day that we held this business after we put it on the table. So like, guys, there's no point trying to be smart here. Let's do things the way we should do. Let's drill this well without the Christmas tree in place. And that's why that guy there was selected. So we went ahead and chose this particular scenario. That helped with choosing that scenario. That's just not it. So we went ahead, chose the scenario, but we went ahead and did an expectation curve. So with a probability expectation curve, we put in all the scenarios here and we them at particular probabilities. Then we created a cutoff. That's 50% that everything we have highlighted will happen, and it's 50% that it will not happen. That's why you see the highlight at 0.5. How many days? Now this is the only we applied some sort of deterministic idea to everything that we did. We've factored in all the models, all the scenarios and everything. But for us to give management a good number that, look, this is where we think we will be. I mean, this is factoring in everything from the good to the bad to the ugly, everything that can happen. If we imagine that it's a 50-50% chance that it happens or it doesn't happen, where's it going to put us? And he told us that, look, guys, 58 days, that's where we'll be. And in 58 days, we'll spend about $50 million max. So we went ahead and drilled the well. This was what the well looked like. So this is what we abandoned. Already the well was existing before. We had produced the first leg and produced the second leg. This is the leg we abandoned, then went ahead to drill the third one. So this is what was done, and we eventually produced it. And so we eventually completed it. And because we had to use the deterministic model, which is, I mean, pretty much the rule for the company, we planned it for $42 million at 45 days. We finished with $47 million at 56 days. I'll show us a quick summary too. The FE method here, so I've just broken it down. The actual drilling time and cost, the time was 56 days. The cost was 47 days. Sorry, 47 million. Using the deterministic method, pretty much standard rule, the FE method that is approved by the company, it was 45 days at 42 million. So you can look at the variance. The percentage error is about 19%. But with the stochastic method, applying all the potential risks that we knew we were going to see, then using the P50 cutoff, we predicted 58 days at 50 million. So look at the variance. We finished with 56 days. Here we have 58 days. That's about 3.5% percentage error. And the cost is about 6%. So that's how close we were. And at the end of the delivery, when we shared this detail, I mean, because we finished this study and we packed it, then we went ahead to drill the well. Then after we drilled the well, brought out the results, made a huge comparison, and that's what gave birth to this paper. So this is a quick summary of what I just shared on the last slide. The actual drilling time and cost, deterministic, the cost, the analysis, deterministic method, and with the stochastic method and risk analysis, this is what we have. So in summary, what the stochastic method gave us was more, will I say more correct or closer to the actual time, or closer to the actual timing when after the well delivery. So a couple of recommendations came, and we recommend to apply it, especially for projects that we expect to see failures or very new projects, especially in the very conceptual stage. It's good to apply it. We see that applying it gives us more accurate results. And for projects where we have very high uncertainty. So again, I repeat, it's not just for drilling projects. Any project that it's possible that you're going to see there are going to be a lot of uncertainties, there are going to be a lot of risk. There's nothing, I mean, go ahead, apply it. Think as much as that can go wrong, as much that can, not just wrong, right as well. Build out the model. It gives the model more, it gives the model more flesh, and you are closer to the right answer. Finally, it's recommended to reference experience from offset records, because yes, a lot of details from the internet we took to study this well, and that's what made me actually think about writing this paper, because when we were about to do this work, I searched the internet, I did a lot of study, did a lot of reviews, tried to find out information on how we're going to do this intervention, and nothing was forthcoming. So I made it a task. I said, look, guys, I'm not going to, hopefully another person does not suffer the way I suffered in trying to put a base of design together and a program. And that's actually what gave birth to this paper. So finally, future study technology and updates. With AI in place now, there are better ways of actually doing this instead of doing it at the time. This paper, I think I presented in 2016. There are a lot of better ways to do it now. Supervised learning, I mean, you could do that with some regression analysis, get all the information. By the time you do regression analysis, you're able to see what fits a particular area. Perhaps an area known for wellbore stability. If you come in there with the number of wells or number of sections I've seen, those sort of failures, you can use that data to better plan your well. Or better still, use a hierarchical or supervised learning where you apply k-means clustering. So that's pretty much like the centroid model. So you take a particular well and look at the offset wells, the closest well to it, and with that you're able to make more informed decision. You might not use, maybe you have a well sitting right here, and maybe the closest well to it is about 5 kilometers, but you are using information from a 10-kilometer well to plan that. Yes, it's going to add some value, but using the clustering method, which pretty much looks at your centroid, it's like a centroid model that takes systems or events closer to it and uses that to use that to enhance the model. So you can actually use that and come up with better decisions for your model. So just for a quick reference, it's from a paper and my team wrote in 2016. The number is 184261. Just thought to share that. And just in case you want a couple of my paper, well, you can find on a YouTube channel I have, where I put a lot of well engineering details. You can get the details on here. Extreme well engineering. And the passion is so that a lot of other engineers around who are coming up, who have interest not just in petroleum engineering, but drilling engineering specifically, don't suffer as much. I wouldn't say suffer, because yes, of course there are data, but to watch things and listen to things that you all agree with me, it's easier to imbibe. When we're all in secondary school, when they tell you you put litmus in acid, it turns red, you put it in base, it turns blue. It didn't stick, but I can tell you for a fact that the first day you witnessed that experiment, it stuck. That's what watching videos and listening to things are like. So thank you very much, ladies and gentlemen. I feel real privileged to be here and sharing this with all of you and the team. Thank you so very much for this opportunity. I can take your questions now.
Okay, just hang on. I think the moderator had a technical issue, so I'm trying to bring her in back. Thank you. Sorry, the time. Yeah. All right, Princess, over to you. Thank you.
Okay, thank you, Odio. I want to start by thanking our instructor for this evening. Ugo, that has been a very exciting and very insightful presentation. I must commend you for the simplicity with which you have distilled such information. And I would give a bit of a summary before we invite questions. So should anyone have questions, please drop your questions in the chat box, or you can use the raise your hand feature so that we can call you up to ask your questions. I'd like to also recognize we had a lot of ex-team senior members join us in the course of this lecture. Some have even been with us from the beginning. I want to recognize Mr. Efiongo Kon. And similarly, I also want to recognize Mr. Mohammed Othman, amongst many other persons who have joined us, various board members from Lagos section, and similarly other sections as well, and various professionals. So thank you for your time. I want to start by reiterating something that Ugo mentioned. While it may look like something focused on drilling, well engineering, but he has provided us a base for being able to make engineering recommendations to management using a risk-based approach, where management clearly understands the exposures of different scenarios that could have been utilized to be able to abandon that well from the reservoir that had been watered out and be able to produce the zone in which they wanted to produce from. So that's something to take back, because when you are going to present, you would need to have a sound technical basis upon which putting forth your recommendations. And management wants to understand, what does this look like in terms of cost savings? What does this look like in terms of the risk they're exposed to? And it was based on that analysis that, Ugo was able to tell them, this scenario where you're trying to save time, save a few days based on having to drill with the Xmas tree, based on the analysis he had done, it looked more profitable and less risky to be able to take out the Xmas tree, and so that was damaging it. So Ugo started from, giving us that basis, how we should think as engineers and how this can be applied whatsoever field we're utilizing it. He applied it for the project that they were doing. He also was able to tell us the different scenarios they were looking at, the scenario where they would have to retain the Xmas tree alongside the BOP while drilling. But the implications of doing that is you could have lateral vibrations to the Xmas tree and then you damage it, and similarly now have to replace that Xmas tree, which will cost somewhere within $7 to $10 million, which will make the cost which would have been saved from the shorter amount of days, it would make it, less ineffective. But he took up as well as far using the scenario where you have to remove the Christmas tree, then it means that you're spending more days, and then you're looking at the rig day rates and every other cost that is going on into the drilling activity. Then he tried to explain, looking at the approaches towards the risk analysis, whether it's the deterministic method and also the stochastic method, and gave us both the merit and the demerit of this, and was able to come up with, utilizing the stochastic, method, was able to come up with, different scenarios, which I would say was very fantastic, because that would have given the team an understanding of what could happen at different phases, while they are retrieving the Xmas tree, while they are choosing to stay with it, prior to while they are abandoning, having to run back in to drill to the section, run the completions, and finally now come out. So having done all that, he came up with different results for his P10, P50, and P90. And given all of that, he was now able to present the scenario, have a better view of what that looked like in terms of the cost range, considering that if he was drilling with the Xmas tree there, it could vary from somewhere around 32 million to close to 88 million, and also giving the duration. And similarly, looking at it from when you have to retrieve the Xmas tree, then could also fall from 34 million to 66. And that gave the basis for him to say, it's quite close. If you want to save just 2 days, but it's quite close to be able to still utilize the retrieving the Xmas tree. And then having now gotten the actual day rates and the actual cost and the actual duration incurred, then when they compared it with the figures that they got from both the deterministic method and the stochastic method, he was able to see that it's very close. And this he has published in an SPE paper, which he referenced
Similarly, so now telling us that there are methods in which we can utilize today to be able to perform those analyses, whether it's through the supervised or unsupervised learnings. So this will be the moments where we will take questions, and I will go through the chat box. So if you would like to also say your questions out, I would ask you to raise your hand, but at this moment, Ugo, I will read out the questions one by one and ask you to take them. So the first one I have here from Ade Solari says, which technologies available today could have enhanced or improved the operation? Ugo, get that?
Yeah, I got it loud and clear.
Okay, please go ahead before I go on to the next question.
Okay, thank you very much. Ali, thanks for that question. I would have been very surprised if I didn't get a question from you. So technologies today, so I'll start from before deployment. So that's assuming this field was planned from scratch, then currently where we are. So like I said, with the technology, first of all, they would have thought about, I'm sure they didn't have in mind that they're drilling through these trees when they were deployed. So firstly, in the FDP, or rather in the initial plan of developing these assets, they would have run trees, because as you have these trees, there are trees that you can actually drill through. Then secondly, another way we would have done this is, I think we were a little bit very, I won't say greedy is not the word, but I think the well would have been placed in a way that we didn't have to do horizontal wells. So without doing horizontal wells, that reduces the risk. So I'm taking the answer in stepwise method. So number one, I'm looking at it that this field hasn't been developed. So firstly, what would I do? Or what would we do? The first thing is ensure that part of the long lead items or the trees that you're going to be buying for this asset are trees that you can, while doing it, you can also drill through. So that's the first thing that you do. Then, looking at what we currently have, trying to fix the problem we currently have, I believe that instead of drilling a horizontal well, yes, it's true that some of the reservoirs we had there were thin bedded, but I think we would have been able to drill these wells in such a way that they are not so high angle. That way we don't think of high rotation to clean the well bore and get the cutters on the high side. We just drill something, inclined but close to near. That way we'll still be able to drill through that tree with the weir bushing that we have. And perhaps we could maybe as we are drilling, because up at the time, as you're drilling, you are inspecting. As you're drilling, you are inspecting. At least you have 3 to 4 inspections before you get to your section to the end out. Because it had actually been done before, but why they did that at the time was that it was just 400 feet that they drilled, and the tree didn't have any issues. So where this was a problem was the length to be drilled was a lot longer, and the inclination was a lot more. Looking at the technology as per costing now, I mentioned there are a couple of ways you could do it. There are a lot of tools that we can use now. For example, I dabble with Python. I know that if I throw in some of this data in, you're able to crunch them and get yourself, do some supervised or unsupervised studies on them and use them to enhance your model. I answered the question in 3 ways. I don't know if that addresses what you're asking, sir.
Okay, thanks, Ugo. That addresses it. And I believe that addresses about the other question asked by Chukwudalu that says, if you were meant to repeat the same job today, what tools would you use today? So I'll go on to the question by Chimere. Is there a risk that applying too many worst case scenario contingencies can make some project or wells uneconomic.
Absolutely, absolutely. So I think I mentioned it when I was speaking. For example, when I was talking about unsupervised learning, and I was making the example, I was using the example using the K-means clustering. I said it's actually not smart using a well. For you have say 20 wells in a particular field, then you are using a well that is say 20 kilometers to design a particular well when you have wells that are 5 kilometers, 2 kilometers from that particular well. So the K-means clustering look at the center. It takes the subject well and relates it to objects closer to it. And by doing that, you are being more factual. Because, for example, if you go and use, you got say the well that was 10 kilometers away or 20 kilometers away had wellbore stability issues, then you are saying, okay, because that well had wellbore stability or there was a fault there. You now say because that well has fault there and they had total losses, you are going to factor that into the current well that you're planning. And meanwhile, maybe you are miles away from that active fault. You are miles away. Maybe when that well was drilled, it was drilled parallel to that fault. Then you are now drilling perpendicular to the fault. Then you are now applying the same magnitude from the plan. The planning that was done there here. So yes, Chimere, if that there are risks doesn't mean you just apply everything. It's just, of course, it's going to overbloat. It's going to overbloat the timing associated with the operation that you've planned for the operations, and with overbloated time, you have overbloated cost, and that will definitely scare whoever it is that is going to be investing. I don't know if that answers the question, Chimere.
Okay, thank you. At this moment, we don't have any new questions. To the question regarding getting a copy of the PowerPoint or the recordings, this recording would be uploaded on the section's YouTube page, so you can equally reference it. And if we get opportunity from the speaker to share the PowerPoint, then that will be shared. Else, would ask that you please reference the SPE paper that you had already written on this to get more information. So if there are no questions at this point, I want to, on behalf of the section, thank you once again, Ugo, for making out time to take on this topic on utilizing risk analysis and probabilistic methodologies for subsea intervention operations. It has truly been an insightful one, and we have learned a lot, and we hope to apply this in the different areas of expertise that we find ourselves in. So with that, we would progress to the next set of activities. We will take the announcements prior to taking the vote of thanks. So I would call on Decoy Elshimir because for that.
Hello.
Okay.
All right,
okay, please go ahead, Chimere.
Okay. Thanks everyone. Once again, I'd like to thank. Confirm you can hear me.
Yes, we can. Please go ahead.
All right. I'd like to use the opportunity to thank our guest speaker, Mr. Ugo. Personally, I think I learned a lot from this session. A lot of steps that are maybe new vaguely, but I think he tried to buttress a lot of it and provided a new perspective for me personally. So on behalf of leaders, I'd like to thank you, Mr. Ugo, for taking out time to deliver such a beautiful and insightful lecture. Also, I'd like to thank SPE Lagos for organizing this session. I'd like to thank all our members, our senior members who have taken out time to join us today to be part of this workshop, and also to all our members, both students, young professionals who are all here. So I thank you all and hand it back over to Princess.
Okay.
Okay, I think I should take the announcement as well.
Yes, please.
All right, just to give you a recap of some of the activities coming up for SPE Lagos, so we can all mark calendars. So we're going to have a lot of events like this. This weekend we're having the citywide catch exam. This is targeted at secondary school students. That will be holding this weekend on Saturday by 10 a.m. So for the invited schools, please let's reach out to them so that they can come around. We'll also be having our technical meeting again. I think it should be our board meeting on the 29th of February. That's next week, Thursday. And upcoming, we do have a technical symposium. Our technical symposium is, the theme of that technical symposium is marginal field, pace setters, the approach, challenges, and journey to first oil. So at this symposium, we're having a lot of marginal field operators come talk to us about how their journey, right? There's a lot of buzz on the space right now. A lot of companies, new companies coming into this space. So we would like a few of them to come talk to us about how, you know, as like for others who are trying to get into that space, let's see what lessons we can also learn from them. In addition to this, so our homepage, please do well to follow us on all our social media handles. That's the best way to keep abreast with some of the information that I do earlier. We post a lot of them on our social media handles. Follow us on LinkedIn. I think the pages are all shown on your screen there. On X, on Facebook, and YouTube. And to renew your membership, this is the beginning of the year. This is that time of the year where we try to renew our SPE membership. Please reach out to our admin or John. We have his name and phone number on the screen. So take out to send an email to us, and we'll reach back to you to help renew your membership, SPE memberships. So I think with that, I hand back over to Princess.
Okay, thank you very much, Chimere, for that vote of thanks and also announcement. So if you know, just as Chimere has mentioned, the section has various activities that are going on, whether around technical knowledge dissemination or around community development initiatives or various competence development initiatives. So should you want to be a part of it, please reach out to the section through the different social media handles or through the contacts that have been shared. Similarly, should you have any questions, we would be able to take your questions, you know, outside of this meeting. So we would be proceeding to take a virtual snapshot now, and we would appreciate that everyone on the video as much as can. I would love to see your smiley faces, and we hope that you participating in our future sessions that are planned. And should you want to also give a technical presentation, just as Ugo has done today, please reach out and we'll be able to accommodate that as much as possible. So I would ask that we all turn, as much persons as can turn videos on, while John will help us coordinate the snapping. So audio, please confirm people can turn their videos on.
Yes, people can turn on their videos right now. Thank you, Princess. And I have some videos already turned on. Okay, the only difference now is I have to make them smile. All right, let's smile.
Oh yeah, they're smiling. Some things are smiling.
Okay.
I may have to call names so that people will smile.
Yeah, okay. Thank you.
Thank you, Sir Festus, for joining us. Thank you. Thank you, Ephraim, for joining us. Ovie, Chinyere, John, Ude, Ogaga, Favor.
Okay, so let's just do a thumbs up. When I say SP, you just do your thumbs up you say your favorite. Very well. So let's just do SPE. Thank you, and I will just take. Thank you. Thank you. Yeah, Princess, that'll be all from here. Thank you.
Okay, thank you everyone thank you everyone for joining us. Thank you very much. We would bring this meeting to a close just about now. Stay in touch with us through our various media handles. Thank you once more to our facilitator, Okoli. Till we meet again.
Thank you.
Next time.
Thank you, Princess.